Okay, let me give you guys some more practice. So integrate this by using substitution. So if you zoom into this bit here, if you differentiate this, it will give. If you differentiate this here, it will give you 3x squared plus x. Sorry, plus 1. So you can see this is very similar to this. So you can make the adjustment. So what I'm trying to say is maybe you might want to try making this as u. So u equals x to the power 3 plus x, and then du equals blah blah blah, and then make the adjustment so that this will cancel out. Well, do whatever you want. Integrate this by using substitution. So press pause and have a go. Okay, so to do this, let u equals this. So if you let this equals u here, when you differentiate this, it will give you the 3x squared plus 1, and then dx. Divide both sides by this thing here, then that will give you this. So now we can put this into here. So this really becomes u to the power 5, and then take this down, and then times it by, well, put this into the dx here. You see what I mean later. Okay, so the dx, we're going to put it into here. Okay, and then the u, we're going to put it into here. So this whole thing here will become this. Okay, but by right we should change this to a u, but let's still leave it for the time being. The point I'm trying to make here is that if you put this into the dx here, okay, then it will become this. So this is us putting it into here. So basically, this box here is this thing here. Okay, so now we just need to rewrite this in such a way that the 2 here will cancel each other out. But basically, factor out the 3 here. Okay, so factor out the 3. That factor out the 3 here. So it will become this. Okay, so if you look at this here, 3 times this, that will give you 9x squared. 3 times this, that will give you 3, and so on. So now imagine this is being multiplied to the top here. So this will cancel out with this. Okay, so that will then take you to here, and then maybe remember earlier u was x to the power 3 plus x. So we can put this into here. So we can put the u into here. Okay, so that will then give you this. Factor out the 3. That will then factor out the take out the 3 here, and then now integrate this. So when you integrate this, it will become this. Get blah blah blah. It will take you to here. Okay. So next one here. Yeah. So integrate this by using substitution. So if you your eyes to zoom into this bit here, you notice that if you differentiate this bubble here, it will become 4x to the power 3. Yeah. And then notice that this is very similar to. Notice that this here is very similar to this, and then make the adjustment. Okay. So anyway, do whatever you want. Press pause and have a go. Okay, so to do this, let u equals this thing here. So let u equals this. So du equals, well, when you differentiate this, du equals this thing here. Divide both sides by this. That will then give you this. So dx here equals this. So now we can put this into this dx here. And don't forget the u goes into here. So it's really u squared. It's u squared here. Okay. Well, substitute, and then it will give you this. Okay. And notice that notice that these two will cancel out later on. So that will then give you this, and then imagine it as two fractions. So you've got blah blah blah. Take this thing out, then that will then give you this, and then blah blah, integrate it. So when you're here, if you integrate this, you are looking for something that when you differentiate it, it will give. You're looking for something that when you differentiate it, it will give you this. And that, well, in this case, it will be -1. But when you differentiate this, it will give you -1 u to the power of -2. But you want to negate this, so you stick. Well, we've done this many times. So from here, that will then take you to here, and then blah blah. Substitute u back into here. So that will then give you this. So overall the answer is this.